No. Amita, is the sound better now?
Yes, your sound is better.
হ্যাঁ, সপ্তর্ষি শোনা যাচ্ছে। It's better.
অ্যাকচুয়ালি ওই সৌর্যর কাছ থেকে আমি কনফার্মেশন পেলেই শুরু করে দেবো যে আমাদের ইউটিউবে সাউন্ডটা আসছে, সাউন্ড নিয়ে ইস্যু ফেস করছে। সায়ন্তনী জয়েন করলো। Oh, okay. Then we are good to start, I think. Okay, so very warm and good evening to all of you. Okay, so we are very pleased to again I can hear an echo. Okay, maybe because of my phone set. All right, so we are very pleased to start our session. This is our first meetup on the virtual platform after a long gap. So we used to meet quite a lot offline, and this is a continuation of that. So you may be already knowing about this data science group, and the data science lab that has started from 2019. So you might be already knowing that our PCs and servers were funded by TechWay, and there is also funding from LISA and USA for this particular lab. So in our first session, we are going to talk about one of the research works done under the mentorship of Professor Chakraborty and led by Professor Das and some students, Shantani, and interns like Rohit and all. So they will let us go through what they have done, and we have thought of not going into a webinar mode. Okay, so we'll make it question answer, and we will try to take as many questions as possible. Okay, so I think without further ado, let me invite Professor Das and his team. Okay, and first of all, I would like to know from you that what is the state of art of data science research as far as medical imaging is concerned. Okay? What is done on disease prediction side, and also tell us a little bit about X-ray image. So I see that your work is more concerned on the X-ray image.
Right. Yeah. So thanks, Saptoshi, and I think this is a very good event, as you rightly told. We used to physically meet in the A.K. Chaudhary School of IT campus, but I think the virtual mode is also equally good. So at least we can. So before addressing the question that you mentioned, let me quickly first talk about the team that we worked together. So it was me, and from the other part of the team, Shantani Ghosh was there. Shantani is a MTech student in the A.K. Chaudhary School of IT. And we had very bright 3 interns coming across to the data science lab and working with us. They are Rohit Datta, Samiruddin Thandar, and Sachin Agarwal. So 5 of us under the mentorship of Amnan sir, we actually worked on this project. Now coming to the question, what is the state of the art in medical imaging related work in data science? So I will take it in 2 parts. Okay, first thing is what types of diseases are generally detected, or we use predominantly data science techniques in what kind of diseases. Many, but some of the salient ones which all of us may be knowing, or maybe few of us may not know about it. So one very predominant disease detection is cancer detection. And when I say cancer detection, it includes every variant of cancer detection, like skin cancer, breast cancer, normal, any other limb, whenever we have a malignancy, trying to figure out from the medical image, what is the stage, first of all, whether the tumor or whether the particular patch is malignant or not. That is the first thing to ensure. And second thing, we always try to go a little deeper into it and try to find out the extent or the kind of progression of the cancer. So there, the use of different data science techniques has been extensive. Okay. Second, where also we have seen a lot of adoption of data science techniques in the area of ophthalmology. Say, for example, diabetic patients, it's very common that they develop a blindness from prolonged diabetic problem, right? So they are also taking the image of retina. We can figure out that what is exactly the extent of damage, or what is the stage in which the problem is. So diabetic retinopathy is another very common area where data science techniques, especially leveraging the medical images, have been used for a long time now, and currently it is even more used. So that's from a disease perspective. Let's shift our attention a little to the different types of medical imaging which are being used. So predominantly we see the adoption of CT scans, we see the adoption of MRI, we see X-rays. Okay. Again, many of us already know about it, right? That what all these different images are all. So just give a quick introduction. So X-ray is a basic 2D image of a particular part of the body where we want to scan through, right? Say for example, chest X-ray. When we talk about chest X-ray, basically we try to get a image, a 2D image of the chest. And from there, we try to find out different types of diseases, right? Again, we can come up with different predictions related to the lungs-related diseases. Okay, so it can be heart-related diseases also. So X-ray is one basic type of image which is being used for this kind of diagnosis. The second, I should say, enriched view or enriched image, CT scan, right? Where instead of one single 2D image, multiple 2D images taken from different angles are being combined together to give a more of a 3D kind of a view. Again, when we try to look at a problem or look at the problem area in a more intense way, we try to go for a 3D image given by the CT scan, and that in a much more enriched way, which is being given by the MRI images. So again, all these variants from the MRI, from CT scan, from the chest X-ray, we can definitely apply the state-of-the-art deep learning models, the CNN models, right? There are multiple CNN models, maybe we can discuss a little later. So different CNN models we can use and come up with the clue whether a particular disease has happened or not, or if there is a particular disease which has happened, in what state it is, what condition it is, right? So that is more or less, if we just try to cover in a nutshell the kind of works which are being currently done. And obviously we are going through a pandemic situation, right? So at the moment, a lot of attention, a lot of focus is being given to the COVID detection. Whether a patient is COVID positive or not, that is being detected using the different medical images, right? So that in a nutshell is about the different state-of-the-art uses of data science in detecting diseases using the medical images, right? So does that answer your question, Saptoshi?
Yes, I think that was quite an elaborate answer. Okay, thanks a lot. Okay,
Yes.
so now would you like to talk about your current research, like what is your current research topic and what motivated you to pick that up?
Okay. So basically, our current research, which the team did it, and we actually also have published some work and doing some more work. So we try to focus on the most simple version of the image, medical image, which is the X-ray. And there is a reason for that. First of all, let's try to think about the current situation, the pandemic situation. What motivated us, right? So when we were looking around, what we could see is this particular disease, COVID-19, or what we say novel coronavirus, it spreads very rapidly, right? And the extent of spread is so fast that even before you can figure out getting infected, some more multiplication happens, right? So one of the biggest, I think it's a concern at the overall nation level and at the global level actually is to kind of detect the infected people as fast as possible so that they can be segregated from the lot. I mean, from the other rest of the population, right? What we call isolation, right? So for doing that, the existing testing techniques which were being used, primarily based on the swab and all, those are extremely accurate in terms of coming up with the decision whether the person is infected or not. But the challenge, there are few challenges. The first and foremost challenge, the time taken for such detection is extremely high. So by the time a person is confirmed to be COVID positive, by the time itself, he or she comes in contact with a many number of people. So that becomes a big issue, right? So that's one thing. Identification process is a long-term process when we look at the traditional testing techniques. The second thing, again, very important in a country like ours, the cost of testing is extremely high. So each of the kits cost around 3,000 rupees. It may be more even in certain cases, right? So, and again, there might be repetitions required. If a person is detected to be COVID positive, obviously, till the point of time the person gets cured, at least twice or thrice, that process needs to be repeated, right? So that is very much cost intensive. Third, and I think the most, critical reason, lack of personnel or lack of gadgets, right? I mean, we all know we have gone through a extreme shortage of kits, extreme shortage of manpower who can handle the kits, right? More so when you go to remote localities, like when we are in an urban situation, the situation is still better. But when we go to a little remote area, then we have a big challenge. Lack of personnel, lack of kits is a big challenge. So that's why we thought that we need to figure out, and actually there was some research already going on, so that also kind of motivated us to come up with a low-cost solution and which can give a fast identification. Maybe the accuracy may not be as much accurate as the swab-based tools, traditional tools, but at the very least, it should be able to identify a larger part of the mass at a very short time and at a very less cost, right? So when we did a little bit of a survey of the existing works which are done across the globe, what we could figure out is the easiest and most feasible way to go is for the medical image, and that is in the form of X-ray, because the other forms of images like CT scan or MRI, they are more, all medical facilities are geared up with all this kind of gadgets, right? So that's why we figure out that X-ray being a very, very common and cheap solution, if we base our experiments and if we base our investigation on X-ray images, it's going to be most effective, right? And the impact can be much more far-reaching, right? So that's why we thought that we should be basing our complete investigation and research on chest X-rays, and that's why we started up with the chest X-rays. And what we did was we used a few state-of-the-art models to analyze the medical images, the typical CNN models, and from there we selected a model which is a combination of multiple models and came up with a solution. And as we stand today, the solution is pretty accurate, at least the we were working on, it was giving very, very promising results. So I think we have a reason to be very much, what should I say, upbeat about the solution, right? So that's kind of a gist about what kind of made us work towards a solution based on chest X-ray.
Yeah, thanks again, Mita. That's also a quite elaborate reasoning. So now I think all of us are very interested to know actually how your prototype works.
Okay.
Yeah, so can you give us a walkthrough or something if it is possible?
Yeah, actually, I will quickly share one kind of a bird's eye view of the solution, so that that will kind of make some sense in terms of understanding how the prototype works. Okay, so I will just, if you permit, I'll just share my screen for a moment. Uh, is the screen visible? Can you just confirm?
Yes, it is.
Okay, can you look at the can you see the brief flow?
Yes. Yes.
Okay, excellent. So the way it works is extremely simple, right? So first of all, we have a block which is focused for the data generation. So whenever we work with medical images, the form of data that we work with is the image data, right? So what we need to have first to start with is the data, image data. Basically, we have to have images of certain patients who are, or rather certain subjects who are identified as COVID positive, as well, who are kind of confirmed as healthy subjects, not being injured, right? The kind of thing we cover as a part of the data generation. We have the data concept. And the problem with that is there is one standard problem that all of us face. When we try to collect the data and when we consolidate the data, we see there are certain rough edges, right? There are certain things which are not completely ready for getting the model trained with, right? So those kind of pre-processing stuff, and maybe when I can switch the baton to my team member Shantanu in a little while, she can explain about this. So basically, data pre-processing also plays an extremely effective role to make the model successful, right? So that is the second step after getting the data ready. After that, we try to figure out the available models in the research community, and out of those models, can we use a model or adopt a model as is, or should we take a kind of a combination of multiple models and try to build a custom model, right, or an ensemble model, right? So that's the reference architecture build-up process. So here I will just take a little bit of a digression. The way that we looked at it, the concept that we tried to implement here is pretty much like, we all know about medical boards. Whenever there is a critical patient, we all, all hear about different medical boards, right? So all the different experts coming together, and the experts give their own opinion about the patient, and based on that, there is a uniform or a unanimous decision being taken about the disease, right? So we try to emulate that kind of a expert different experts coming together. So for that, what we did was we put in place several state-of-the-art CNN models, and we ensemble them in a very wise way, so that the right model contributes the right information. I'm not going to get into the details of that. You can look into the paper if you want to later on. So just to make sure that the right models contribute the right amount of information in the decision making, we did the ensembling in that way, right? So that was the architecture build-up, the model build-up. Once the model was built up, then we trained the model with the pre-processed data, right? So basically, we had a section for the training of the model, and then we had a separated out section for how well the model is behaving, so testing the model, right? So that way we tested the efficacy of the model, right? So that's pretty much the overall flow of our project, starting from collation of the data, pre-processing of the data, come up with the reference architecture, training that architecture or training the model, and then ultimately finding out how good the model is performing on a test data. Right? So that is how we have come across with the things. Now I will pass the baton to Shantanu. So Shantanu, if you can elaborate a little more about how we kind of collated the data and what were the major processes that we have done, right?
Yeah, thank you, sir. The data has been collected from several sources which are publicly available on the internet. Like CXR images have been collected from a hospital in Spain, in Italy, and the largest available data set that we have got is from Stanford Machine Learning Group, which is also publicly available. And the rest of the images are from Kaggle, GitHub, and other publications. And all this is pneumonia and the healthy images of the patients. So all this data were in the format of JPG, JPEG, and PNG format, and we have converted all this into the JPG format while pre-processing the data. Yeah. So.
And I think we did one more thing, right? We had the images in different shapes and sizes. Yes. So that's another thing we had to do. Basically, we had to resize all the images into one common shape or the one common size so that we can feed it into the model for training, right?
Yes.
Right. So that was pretty much, Saptarshi, that was pretty much about the overall project when the kind of the life cycle what we followed in the project. Saptarshi, you are there? In fact, let me also, by the time talk about the other things, let me also touch upon. So when we tried to select the different models for the reference architecture, there were a few considerations that we had taken. So we considered all the state-of-the-art CNN models, and ultimately we selected based on the performance, based on the efficacy. We actually shortlisted 3 models. First one was the SNET model, which is extremely efficient in terms of disease detection. The next model, which is again a very much state-of-the-art model, is the Inception network, right? So that is another model which also gives a very high amount of accuracy. And the third model, which is a very simple model having a less number of parameters, so that's why it's also a very preferred model. We use the DenseNet model. So we actually used the ensembling of these 3 models, and the way we try to ensemble is whenever these 3 models are giving their view, whichever model gives a better view, in terms of accuracy, it gives a higher accuracy, it is given a higher weightage. So that model is being taken as a major model in terms of decision making about the class, right? So that is the very simple way the rationale that we have followed while building the model. Yeah, over to you, Saptarshi.
Yeah.
I am Dr. Shomosan. I have a question.
Yeah, sure.
Yeah. One thing is that so much research is going on in the field of disease detection, particularly COVID. How are you make sure your results are reproducible and the codes are available to the community?
Okay, so basically 2 things. When we did this work, we wanted this work to benefit most number of people, right? So what we did was the entire source code to GitHub, right? So that's the first thing that we do. So any other research body, any other research group, if they want to use our research and extend it, they can go to the GitHub link and get our code. So that's one thing. And reproducibility, again, when we compared, we tried to compare it with the first of all, reproducibility is ensured by the different parameters that we have taken, right? We didn't make any like hard-coded assumption and all those things, and we have reported whatever parameters that we have used, we have reported as a part of the research outcome. So that is one thing we have done. At the same time, we have also compared with the existing benchmarks to make sure that the model that we have come up with is performing fairly well. So when we published the work, or when we completed the work, existing benchmark was a particular model called Covid-19. It was from a research group in US. Okay, so Covid-19 is a custom network that they have developed, right? And they were yielding very good results, both in terms of accuracy as well as in terms of sensitivity. So when we compared, we had an accuracy better than Covid-19, and even the sensitivity was pretty close to Covid-19, right? So that's how we try to kind of gauge that how good our model was performing, right? Hope that answers your question, Dr. Shin.
Yes, Amit. Thank you for the clarification.
Thank you.
Yeah. I would like to ask Shoujo once that are we getting questions from YouTube? Then we can take them as well. Shoujo, are you there? Will it be possible for you to tell us the questions that are coming in YouTube? Oh, okay. No issues, no issues. So I think we have got an idea already on how Professor Das and team formulated the problem and approached the problem. And I'm sure that will be quite motivating for at least for new researchers who want to undertake some researches. Okay. Now I think sir is there, Amlan sir is there. So I would like to ask sir, if you could brief the participants on some of the researches that are going on, data science lab. Okay, I think it will be a good platform where people can come to know about it.
Yeah, very good. Very good evening to all of you, and thanks Shaptoshi, Amit, and Shoujo to organizing this. And I also welcome Professor Bharshati Ganguly here. She's there in this meeting, and all the students and all the collaborators of the data science group of University of Calcutta. This is actually hosted at School of Information Technology. Just to say a few words about this particular data science initiative. This is presently hosted in the School of Information Technology, but this is a collaborative lab. So we have other departments like Department of Statistics, which is a very strong collaboration we have, and they are also very well connected with this particular lab, the projects and the research activities. Also, we have some activities with Department of Biochemistry, Computer Science, Radio Physics and Electronics departments of our university. Now, regarding the data science lab, obviously this was being initiated by the research scholars, that means who are now pretty senior in their professional career too, like Shaptoshi, like Amit, and well supported by our faculty members like Dr. Shomo Sen and Dibyendu Shil, and obviously now the present batch of students and collaborators, interns. So the motivation of the data science lab was that means we explored. Actually, myself was working in the domain of computer vision for the last 6 years. We also initiated a lab, a research facility called Center of Excellence Systems Biology and Biomedical Engineering in 2014, and I was the principal investigator of that project funded by Ministry of HRD. From there, we started started looking into the problems. So my domain in that particular research group was to explore the areas in the domain of computer-aided diagnostics and detection. So detection and diagnostics. So we started some work initially, and we got good fundings both from UGC as well as from TechU, Ministry of HRD, and we churned out good research scholars. Then obviously we started 2016. We started very strong research activities generated by Saptarshi. That time he was a PhD student in our department, and then followed up by Amit, and simultaneously the activities of big data, which was started by Showmotion. These all got actually morphed in this particular place, well supported by the Department of Statistics, like Professor Bhashwati Ganguly and Professor Shubhata Sen Roy. So these all actually cemented our activities. Now we are actually looking into multiple avenues, okay, like medical image processing, computer-aided diagnostics. This is one of the key areas where many of our faculties and students are working. Apart from that, I think there are works which are going on, like machine learning domain, like the feature selection and how to handle large data, classify large data, and how to tune up the feature space. Similarly, we are working the areas like text analytics, and I think a couple of students are working. Regarding the projects, we are venturing into new areas like quantum machine learning, and we have a funded project in this domain, which is supported by Department of Science and Technology. This is a collaborative project between the Iwate University of Japan and our department, and we have the collaborator like Bashabi Chakraborty. She is one of the collaborators in this particular project on the Japanese side. So we are actually looking into a couple of problems. The problem here is that can we have the machine learning algorithms can be implemented through quantum machines, right? And whether we can have some gain in computational process in terms of either complexity or in terms of resource, right? Because we know that quantum compute are that means you can increase the power in the exponentially once you increase the resource in the quantum domain. So can that help the quantum domain? Also, we are trying to see that in some of the computations in the quantum domain can be quantum classical hybrid, whether we can have gain in that directions. There are also some activities like soft computing in the quantum domain, and there are recently some breakthroughs we have achieved. I'm not disclosing that breakthrough. Probably what comes out in that, we will be able to announce that what we have achieved. We are also exploring the possibility of cybersecurity and machine learning, and that are coming through the project funding from the DRDO. We are not, that means in the public domain, we can't disclose much about the DRDO project, but it is something where we try to analyze some of the crypto ciphers, right, and try to see some of the properties of the crypto ciphers in terms of signature analysis, trying to find some of the properties of crypto ciphers in that domain using machine learning. There are obviously some of the new activities initiated, some collaborations to industries, like Saptarshi and Amit know that they have already started some collaboration in the domain of explainable AI. So this is not yet a funding, but this is also pretty interesting because there are a lot of the industry has interest in this particular activity, and collaborating with our group, with our data science team, and we expect that the PhD students, the master's project, the undergraduate projects, as well as intern projects will churn out in this area too. There are also a good amount of activity going on in bioinformatics. Actually, one of our faculty members, Dibendu, is working in this domain, and recently, today I had a great discussion with one of the big industry players who are interested to look into and to work with us in the domain of bioinformatics and obviously processing and bioinformatics, and obviously so these are the things which are there in the plates, and we know that there are a lot of industry initiatives are connecting with us in either in short phase of projects or in long-term long-term in require, that means in the direction of product development. And so the next challenge for us is to scale up our manpower, to motivate our students, to have the good researchers who are in our team to be with us, right? And obviously the support from the faculty members, not only from our department, but from the other related departments of our university, like some of the departments in engineering faculty, department of statistics, department of mathematics, and actually the crypto project what I am doing is also a collaboration with the Department of Mathematics in our University of Calcutta. So these are the things, and we are in a good shape in the form that we just started in 2007. Detail that in which year we just that means made our lab corridor. Okay, put that frame, that is a data science lab funded by, and obviously we have the funded project of LISA, which is still going strong with the collaboration with Department of Statistics and University of Colorado. So a lot of things are there, and I feel that there will be not dearth of projects, but only the thing is that we know that to retain the manpower, to have the best manpower in working in this particular lab is our motivation. So our faculties and our now present researchers like Amit and Shaptoshi are scouting for manpowers. They are always discuss with me that, sir, there is a good student and good internship and good industry requirement or good industry projects are there. But you know that in terms of our other activities in the university domain, we have a bandwidth. So we are open to the activities which can give us. We are always supportive to collaborations. We are always supportive to interdisciplinary activities in the domain of data science, because we know that it is a vast area, and we are still we are in the peanuts, right? Still we are only maybe some part only we have explored through our experiences, and it's still a larger part remains unexplored. And so these are the issues. And regarding there are also, as we handle with data in the domain of data science, there are a lot of other issues which I don't want to that means much discuss here, like the ethics, like the reproducibility, what very well questioned by Dr. Shomoshen, very well answered by Amit. So these are some of the issues which we want to continue and which we want to maintain a very gold standard in this dimension. We want to publish good papers in good journals and conferences. We want to look into good projects and collaborations, and that's the motivation we are setting up. And it's not me or Shaptoshi or Amit. It's a team we are working out, and we know that if we can work out in this particular team, we can obviously take up some good challenges, and we can obviously train up some good students. Actually, today the discussion was mostly from an industry who wants their people to be trained by us, right? And I will discuss with the team after this meeting. So those are the horizons we're looking forward towards, Shaptoshi, and we all are trying to make the best of our efforts and driving this particular data science lab, which is very new, but which is actually coming up in a very impressive way.
So thank you so much, sir. I think it touched all the aspects. One thing, sir, I would like to know more from you, if it is possible, about the computing facilities. If you would like to share, because all these deep learning and machine learning things will need GPU and all.
Yeah, so that's a good question. Actually, we are trying to scale up in computing. Obviously, as Shaptoshi rightly told, that computing in the domain of deep learning doesn't only mean our desktop or laptop systems, because we require storage to store the data. We require GPU systems to concurrently process the execute the algorithms which works in the parallel domain. So we have recently installed a facility, and I think some of the students like Amit and Shaptoshi, some researchers, Amit, Shaptoshi, our Shomo, they are already connecting with their system. So we have installed a cluster computing system, which is a central facility in our technology campus, and that facility consists of 4 computing nodes, one master node which will work as a scheduler for all the jobs, and we have one GPU computing node. And the plans are like that. If we require the way the cluster has been set up, if we require, that means if we feel that the requirement is getting shared, then that means that our requirement is greater than that. Though greater if we have around 100 plus users in this facility. Okay, provided we can reach that, then obviously there will be some sort of, we will upgrade it obviously, and we will actually speak with our authorities to upgrade that facility with the funding. And also we have some sort of, apart from the centralized facility, in the last year in our department, we have actually installed a mini cluster, which consists of one master, one compute node, and one GPU. So the motivation is that the master's projects, or that we have 3 courses like MTech, MCA, and BTech. So the student projects can target those HPC, the mini cluster system, and the senior researchers of our department, as well as the PhD scholars, can target the central GPU, which is the central facility. And I think this is the first step. I am not telling that this is all we have solved our all computing need to this, but obviously this is the first step, and this is at least the baseline requirement up with this type of data science applications in our lab.
Thanks once again, sir. I think that was also very important aspect of the lab that needs to be known. So from the very inception, so we had a kind of a data science group which was there primarily in WhatsApp. So we had 5-10 members. That would be around 2018 January. So now we are testing the limit of a WhatsApp group. So we have people from industry, we have people from academia, research scholars, right? And so now we are testing actually limit of a WhatsApp group, which is 255. So I think very soon we will need to have another group for the same. And various interns have come and worked with us, and our students like Saurabh, Wajib, Shoujo, all of them help in various manners. There are also students from outside the ecosystem, right, or data science professionals outside the ecosystem, like Pallavi, like Shomita, who are helping us, and it is our heartfelt thanks. And of course, I mean, it is all about sir's leadership and blessing. And I don't remember any time we have gone with something, asking for something, and sir has told us no. And I don't know how he manages that, but we have not really heard no so far. Okay, so research part we have already heard, and we have also started with coming up with some open source YouTube lectures, which has corresponding notebooks and corresponding notebooks, as well as training materials. Okay, so some part of machine learning and deep learning has been covered. Professor Das has recently started with his Python lecture series here very shortly. Okay, so these are some of the activities. We are also very soon. We will come up with the website, and actually even again Shoujo is helping us with that. So all the activities that we are talking about will be available in the website for you to go through. And of course, we are getting a lot of internship requests every day, and we try to cater to them. So please go through the activities. Whoever is interested, follow sir's updates on LinkedIn, or get in touch with us, get connected, and that way we can really build a strong ecosystem out of here, which is one of the motivation which gets us going. Okay, so I think that's all I had to say now. And Shoujo, do we have any more questions that is on YouTube? Yes.
what's the question, Shoujo? Can you repeat once again? I couldn't listen that. I couldn't. Yeah. No, we don't have collaboration with that particular company. I don't know that means whether they are the instrument manufacturer or their software. So we had a brief collaboration with GE Digital sometime around 2016. We had a very brief collaboration. One of our students was that was a visiting researcher at GE for a period of I think 3 to 4 months, and then we got some input and some activity in that particular direction. But apart from that, we don't have any direct collaboration with any instrument company. But we are obviously, we look forward to have that, because we know that nowadays the reconstruction of the, so the main issue, that means the one issue of this particular images which connects with the instrumentation company. So there are three players here. That means the three stakeholders here in any computer aided diagnostics. Okay, that means we actually look into the two players. Like the player one is the doctor, okay, who gets the help out of this tool, and obviously the patient, because he gets the service out of that. So the doctor reduces the patient screening time. The doctor reduces, in some cases we have found that that some of the biopsies which are unnecessary, the doctor can hold those biopsies, and doctor can go for very specific biopsy based on the detection or diagnosis predictions what the tool gives. But there is obviously a third that means the third stakeholder which we normally miss out, which is the instrument manufacturers. Why it is also a stakeholder? Because you know that all the reconstructions. Today I was in a meeting with a team with we are discussing with that means the fossil imaging of fossils, whether we can using the CT scan, whether we can actually find out some internal components of fossil, because otherwise those are destructive, right? Otherwise we have to do some sort of hole or some sort of piercing the fossil bone or fossil of the fossil, so without any sort of intrusive that means those type of technique, whether we can do that. So the issue here is that when we try to do this, when these instruments generate the reconstructions, okay, they take a lot of parameters into consideration. There are some minor rotations, minor aberrations which they correct, right? Apart from that, there are some noise sources, right, which are due to the reconstructions and due to the source signals, right, which actually get into the object, get over the object, and they get trapped by this particular sensors. Because everything in the instrument level is the play of the sensors and energy. Sensors pick the energy and how the energy profile is being represented by your tomography images. So now this energy profiles gets aberrated or interfered, and if we have very minute variations in the disease area, those things can come up and can create and can spoil the entire scenario. So now the software algorithm, how they're working with the data and how the data is being produced by this systems, scanning system, needs to be perfectly matched. Okay, more and more they are matched, more and more you can have a better outcome in terms of image representation, in terms of data. Okay, and that's obviously this instrumentation companies, some instrumentation companies like Siemens, like big players like Philips, like GE, they have their own team. They have their own big team, big R&D team, who are actually developing these softwares. Okay, for doing a lot of analysis. But there are other companies who are trying to look into some new domains, maybe 3D tomography or something. They also want a collaborator in terms of this particular software. The people who are developing the tools for computer aided image analysis. And I think those directions are really challenging for us. And if there are suitable opportunities for collaboration, either in research or in industrial engagements, okay, we are very much open, okay, to those things. Yes, so you can pass this message to the participant who who questioned this. Yes. So Amit, can you answer this? Amit, I think Amit is exploring this. Amit can answer this well.
Yes, actually there are upcoming sources primarily from the countries like Italy and Spain. Okay, so there are sources available. Another very interesting research I would like to mention about, there is a particular research group which has come up with a model called COVID-GAN, which can generate images. So lack of patient image is always a big problem. So to address that problem, I would recommend to go through that research work, COVID-GAN, which is used to generate images of patients, COVID patients, right?
Yeah, I think thanks, Amita. Shobhu, I hope there is no further questions. Okay.
Okay, so Amit, if you can give a brief.
Yeah. Yeah. Actually, where the work has been done, as I was talking about. So basically, we had given a higher weightage to the model. So we used 3 state-of-the-art models, as I mentioned, right? So model which is contributing to more accuracy, we have given more weightage to that model, and that way we encouraged in the decision-making process. We encourage the contribution for the most accuracy. I mean, the most accurate model, right? So I'm not going into the mathematical formulation of that. So when we actually calculated the predicted value, we actually use the weightage for the individual models in that way. And we actually came up with a specific formulation to do this. Okay, so that's why I in the last portion of the talk also I told that if you can refer to the paper that we contributed, it has a complete details about how the right.
Yeah, so yes, that's quite an interesting question, of course. And just a follow through. I mean, so the accuracy that you have taken, so was it on the training set or was it on the basis of validation set?
It was on the basis of validation set actually.
Okay. I think that will of course be more robust.
Yeah, exactly.
Yeah. Okay. So I think then we are done, and thank you so much everyone for joining in. Amlan sir, Professor Ganguly, uh, Dr. Sen, and then Dibendu, and of course all our beloved research scholars, Amita and team for demonstrating their work. So I am sure that this will motivate more of our researchers who are doing good work, fantastic work, to come forward and demonstrate. Okay, and Amita, I will also give a link to your research and also your GitHub code so participants can readily access it. They can have it readily available.
Sure.
Okay. Yeah. So I think we are in time, and if I just ask Bhashwati ma'am once, okay, that if ma'am wants to add something, and then we may close today's talking.
Omlan talked mainly about the research done by the lab. I think another great initiative which Shaptoshi mentioned is the short videos which you are posting. So as I understand, they're very short and mainly meant for working professionals, but another big demand area is the demand for degree programs and diploma programs in data science. So I think that's something which this data science lab should take advantage of, and I will request Amlan to follow up with UGC on this. So as you know, we started trying to do so, but then lost it by the communication, which was so long because the MOOC program changed hands from the UGC to another body. But I think we really should capitalize on the need and ensure that we are one of the first who can offer this program.
So, ma'am, in that regard, currently the Python course which has been started, by us. So basically, that focuses on the complete undergraduate syllabus, both BSc as well as BTech, and it tries to cater the need for the whole syllabus. So module-wise, we are trying to capture the whole syllabus and the way it is structured by the different universities. So that is one small initiative we are taking in that direction.
Yes, that's a great initiative. We had at one time thought of a more comprehensive initiative which would give someone a diploma in the area from Calcutta University, and we had actually detailed 5 papers. So somehow that got shelved with the need to start that discussion again.
Yes. So not UGC level, ma'am, but we have made some plans. So I will share that with you.
No, as actually Professor Ganguly rightly told, that we now have to take this up. That means to the concerned level of UGC, and also we have to discuss with university authorities so that this can be done as soon as possible, because we shouldn't miss the bus. And that was always the request, or I can tell the demand from Saptoshi and Amit also, that we should start the course immediately. And also Shaumu and Dibyendu also push that in our departmental level. So this will be a collaborative course which we have already planned well with the Department of Statistics and School of Information Technology. And obviously that means I think we should now again start on that administrative part of this course. Okay, because content-wise, I think we are better now, right, compared to when we planned this. Content-wise, we have planned the administrative stuff. Yeah,
absolutely.
We'll look to that. Yeah, sure.
Okay. So thank you once again, for finding your time and spending your time with us. Okay, and I'm sure we can continue this activity once in a month. So maybe I will float a call for presentation kind of a thing among our data science group and all other research groups, and see some of the things that can be presented. Okay, so thanks once again, and I wish that you stay safe and venture out taking proper precautions. Okay, so signing off then.
Thank you.
Yeah. Thank you all. Thanks
Saptoshi.
for coordinating.
Thank you, sir.
Thank you, ma'am.
Thank you.
Thank you.
All. Thanks. Bye. Bye.